Hi everyone, and welcome back to the next lesson of our Java course. In previous lesson, we talked about the Java variables and how to use them, right? So we will continue our journey to understand some of the core building blocks in Java. And today, I'm gonna focus on to one of the most fundamental concept while you are learning Java, which are the data types. All right. So if you have started your journey, understanding the data types is actually crucial. Uh, every program you're going to write is there is a certain aspect which involves data types, right? What kind of a data you want to store and what is the right data type which I should be using. So having a clear understanding is actually very critical for this one. All right. So there are a few things which we're going to focus on those one. Number one is what we're going to learn is number one is what are the data types. Number two, what are the different data types in Java, right? Number three is how and when to use each data type. And number four is we're going to look into some of the example in data type. All right. So now, before we dive into more of the technical parts, data types are actually used in our real life, right? Let's take a very simple example where you want to order food online, right? So what is going to happen is you're going to call someplace. Let's say you're going to you have decided to eat pizza. You're going to call this pizza place and they're going to ask you certain things before they say, okay, this is your final amount which you have to pay in order to order the pizza. So they will ask you, okay, what's your name? Number two is probably say what's your phone number so they can send you the text message when your pizza is ready. Number three is what kind of a pizza you need, right? What is the size of the pizza, small, medium, large, so and so forth. Then they probably will ask you, do you need any extra cheese on that one? Yes or no? And then a total price for that one. All right. So there were certain things which were involved in this one, right? So number one in our case is if I look closely, so name, right? This was nothing but a string, right? Then I have a phone number that was asked, which is nothing but a number because this is contains only numbers, right? Then they ask us the size. What is the pizza size? So it could be a simple single characters like medium, large, extra large, so and so forth, right? Then they ask us extra cheese. So it was simply yes or no. And then they were telling us, okay, the total price, right? Total price is nothing but it's a number, but it's a more of a decimal, right? Because price is not always going to be a whole number. It can be with some decimal values, right? So if you look closely, these things, why they are asking, because they are putting each thing in a specific thing. Name probably will go into a name column, which is only going to have strings, right? Phone number is only a number, so they can verify those things, right? So similarly in Java, we have the data types. Now, a data type in Java tells the Java what kind of a data a variable can hold, right? So we have learned about the variables in our previous lesson, right? So for example, I can have a variable say age and it's gonna store value as 10. So before this variable, I'm gonna set a data type. All right. So this is int is int for short form for int. So this is my data type. So what is happening in this case is I am telling the underlying JVM that this variable can hold value of type integer. So I am telling my intention upfront to the JVM and the compiler. It's going to help us in many things. Okay. And we're going to cover those one. But you are basically in your variable, which is a label, you are also telling what sort of a information or what sort of a data this variable is gonna contain. Okay. And it basically, there have multiple things. Number one is efficient memory management. So it means you know that, okay, what kind of information I'm gonna hold, what is the right data type, right? So you can also think of something like that. Okay. You can have a big container and you're putting everything there. Like for example, in your kitchen, you have a big container, you are putting everything in there, all your kitchen stuff in that, right? Whether you have anything, your, let's say, your sugar, salt, so and so forth, you put everything in the same box. Is it efficient? No, because putting things is easy, but when you try to get things out of it, you have to search for it, you have to find for it, right? So not very efficient solution. Similarly here, there are different data types, and the entire idea is, of course, preventing error is one of them, but then the memory management, right? You basically know which is the right data type for me, so you can use that data type. All right, so in Java we can categorize data types on a high level into two different categories. Number one is primitive data types, okay, and we're going to focus on this in today's lesson. And then we have a what we call as a reference type when it comes to more complex object. We're gonna talk about reference type when we learn about the object and classes and so on and so forth. All right, so the primitive data type, these are the most basic data types, like numbers, right? For example, numbers, then numbers, say boolean values, yes and no, and so on and so forth, right? The primitive data types are directly stored into memory. So if this is your memory, all these primitive data types stored into the memory. Reference types are stored little differently, so we will talk about those one, right? Other thing is primitive data types, you can break them. So int is int, you cannot break int into something else. A boolean, which is yes and no, you cannot basically break it down further. So yes and no will always remain yes or no, right? Reference types are a little bit more complicated because they contains a lot more complex data, and the way they are stored into the memory is little different. So we'll gonna touch base on those one. So, and one of the reason why primitive data types are called primitive by the language, because they have a predefined meanings. Okay. Now, what is meant by predefined meaning? So let's go back to again to our example of data type, right? So I'm gonna say int age, and let's say age is equal to 20. All right, now when we say predefined, it means number one, the name of this data type is predefined. You can only use int, you cannot use something else, because now Java or the underlying JVM understand int as an integer. That is number one, right? That is why we call it as a predefined, because the meanings, definitions are already built into the Java. Then int also defined what is the maximum data you can store. For example, if you have a billion number, you probably that is not gonna fit into int. You might need a different data type. So every data type, number one, defines what value it can hold, what type of a value it can hold. For example, int can only hold integers. It cannot hold a yes or no. It cannot hold a character value. It cannot hold a decimal values, right? So if you try to store int 20.0, it is not gonna work. This is not gonna work, okay? Because int can only store int values. Okay, all right. So now what we can do is, on a high level, we can further subcategorize primitive type into two subcategories. Number one is numeric. Okay, so numeric is like whole numbers and then decimal values, and then we can also categorize other part as non-numeric, right? Okay, now within the numeric, as I said, we can categorize it as saying number one, let's say integer, and number two is decimal. We'll keep it as simple to understand. On a non-numeric, you can categorize it as, let's say, I will say char, which is a single character, and then I have a boolean, which is yes or no. We can further subcategorize integers, and I'm going to talk about that as well. Okay, so as of now, when I'm recording this video, there are total of 8 primitive types. Okay, And if you want to understand, one is int, then we have a long, we have a double, we have a float, we have a boolean, we have a char, then we have a byte and short. So these are the different variation of those ones. All right, so this was the hierarchy for our numeric one, integers and float. So within the integers, I can basically go ahead and further subdivide this integer into more granular level. So I can have, let's say, byte, which is the shortest one. Then I have a short. Okay, then I can have a int, and then I can have a long. Okay, similarly in float, I can have a double. All right, and then I can have another one which says float. All right, so these four, for example, this one and this one and this one, right? The fundamental difference between these are, although they are part of the integers, but they differ in terms of what is the maximum data they can hold. And that also gonna help us when we are gonna plan out, okay, based upon we know if what is the maximum number I'm gonna get, then I'm gonna decide, okay, whether a int is a right choice for me, or I need a long, or I need a short, or I need a byte. Okay, all right. Similarly, onto the float, there are two variations. Number one is double for us, right? This one, and then float. Again, these are just the float values, decimal values. Only difference is based upon certain criteria, double might be the best fit, or in certain cases, float might be the best fit. Okay, so we're going to cover over the integer types, which are the whole number, and there are certain four variation of it: byte, short, int, and long. Right, I'm going to talk about number one is the short. Okay, short is actually of 2 byte, and I'm not gonna talk about more about the bytes and bits and how they are stored. So 2 bytes means I can store literally a value from minus 32,768 to positive 32,767. This is the range which I can store. What might be the good example? Let's say you're creating a school application and you have to store the student roll number. So in a given school, roll number might not go beyond 1,000, 4,000, 5,000, so and so forth, right? So this is a best use case to store the student roll number, right? Because I know that they cannot exceed, a school cannot have 40,000 students, right? I have not seen such a school. Then that might be a good fit. For example, short, I will say short roll number is equal to let's say 200, right? And if I try to add a value more than 69, you will start seeing this error saying it is actually not a short, it is an int, because in short, you can maximum value you can store is 67. If I do 67, it's gonna store it without any issue. All right. Similarly, if I go for the byte, okay, byte, as I said, is the shortest one. This is a 1 byte information. It can store a value from minus 128 to plus 127. Okay, so you can use byte to, if you know your data will range between this category, right? For example, there might be a switch where you want to store 0 and 1. Those are the only states you want to store, right? In that case, byte might be the better fit, because I know that I'm only going to store those two values. I don't want to use short in that case, because short is a 2 byte. When I know I can store the values in 1 byte, why I want to waste my memory? Remember one thing, computer memory is the most expensive part. All right. Okay. Now, how about the int? So int in our case, if we go for the int, okay, int in total use a 4 byte. So 4 byte means you can probably store something around, I think, minus 2 billion to plus 2 billion. This is the range. It's a huge range, right? What I can store? Maybe a salary of someone, right? So I can say int salary is equal to 100k. Yeah, so I can use int for that number. I cannot use short. I know that short cannot store more than 32,761. So in that case, salary is the right choice for me. All right. And then when it comes to the long, this is the largest data holder, right? This is the within the whole number. You can use the long to store a really large values, right? Long can store, it's a 8 byte, and it can store really a large value. All right. What is a number which probably will fit into this one? Let's say stars, right? So I can say there are so many stars we have, right? Maybe I'm just putting some number here and add it like this. One thing when you are using a long, if I say this one, right? So what is the error you are saying is it says it's an integer. It's still understanding this as an integer, not any long, although I am telling that this variable is of type long. So in order for your compiler to, in order to tell your compiler that, hey, this is a long, you have to append capital L at the end of it. In this case, it understands that, hey, this is a long number. All right. Similarly, when it comes to the floating points, okay, there are two variations of the floating point. Okay. Number one in our case is the float. Okay. One is float, or I will start with the default, which is a double. So double is the default in Java. And let's take an example. For example, price. I want to store price, which let's say 100.30. Okay. So double in this one can store up to 8 byte of data. Okay. Similarly, I can also use float is the another variation. So I can say float. Okay. And I can say, let's say tax, which is, let's assume it's 5.5. Okay, that's a text value. Again, similar to how we use the long, you have to basically, in order to tell your compiler that this is a float, you have to add f at the end of it. Okay. Now, in Java, double is the default data type when it comes to the decimal points. All right. If you don't specify that one, it's going to take decimal as the default value. Now, what is the fundamental difference between the double and float? Float can be useful when you have to save the memory. So the basic difference, of course, float can only store up to 4 byte. But when it comes to the precision, right, it also basically take into account the precision values. Now, the next one in our case is the char, what we talked about. So char is nothing where you can only store a single character on those one, and that character will be kind of added within these single quotes. You cannot use a double quotes. Remember that. If you use a double quote here, your editor is gonna start complaining. This will say this is not a character, this is a string. So in order to tell your compiler that this is a character or a char, short form as char, you have to add it into a single quotes. For example, I can say char pizza size is equal to small. Okay, this is another way of storing it. Okay. Now, there is an interesting thing about the char. Behind the scene, Java uses something called a Unicode to represent these characters as number. I probably will cover that in a different call or a different video, because that needs a little bit more deeper understanding how the things are internally stored into the JVM. All right. Last one in our case is the boolean value, right? Boolean is nothing, but it can only store two values, which are true and false. So boolean, let's say status, which says true or false. These are the two fundamental value it can store. Okay, either true or false. One thing which you have to remember is you have to use true like this. Everything is in lowercase. false, everything is in the lowercase. You cannot use anything other than these. If you try to use, for example, true, it's not gonna work. It's gonna complain saying this is not a number. Okay, so I hope this gives you a clear understanding about different data types in Java. And remember, you have to practice it a lot to understand which data type fits on a given situation. Okay, if you have enjoyed this video, please don't forget to subscribe and hit the bell icon for more such videos. Till then, happy coding, and I will see you into the next video.